Good morning, everyone. Today we discuss about a geomorphological um, chapter or geomorphological topic related to topography and topographic map. Now, the word topography, it is derived from two Greek words. The first one is topo, which means place, and the second one is graphia, means to write or to record. So, together, topography means that it is the description of any place. Now, description of any place can be done in two ways. The first one by which description can be done is by simply write about the place in with using some words, or another way of description of any place is by simply drawing the features what you observe in that place. So in topography, we basically deal in both these two ways. We draw as well as we describe the features what we observe in a particular place or in a particular area. Now, if we now summarize the term topography, or if we try to define, if we try to look the definition of the term topography, then topography is the study of the shape and features of the surface of the earth and other observable astronomical objects, including the planets, moons, and asteroids. So, the subject topography deals with the shape and size of any, or that may be other planets of the solar system, or any other solar system, any asteroid, or the moons. Now, topography of an area could refer the surface shapes and features themselves in terms of writing their description, as well as in terms of creating any drawing or creating any map. So this is the main thing what we mean by the term topography. Now, the application of topography is to determine the position of any feature, or you can say more generally any point, in terms of both horizontal coordinates, that is in terms of latitude and longitude, along with the latitude and longitude, or another character, that is altitude. Now, altitude means it is either height, that is above a fixed reference plane, or it may be referred as depth, that is below the fixed reference plane. So whenever we try to explain topography of an area, we explain the area in terms of its latitude, longitude, as well as altitude, and thereby identifying and name the features what we observe in those places. Now, a topographic study is very important for us. It may be made for variety of reasons. The main reasons for doing topographic study is for geological exploration. So, topographic study is done in various purposes, mainly for geology, which is needed in our day-to-day life, as well as various superficial features, and according to them they can uh, do their plannings. Apart from this, topographic study is also required for any kind of civil engineering project, that is any kind of construction, for construction of any major building, for construction of dams, for construction of tunnels. So in almost every purpose, in almost every steps of our daily life, we need to study the topography of an area. Now, whenever we start or we try to study an area, the area is known as field. That is the region of space or area that has been measured and studied for a given property or a given point. Now, in that area, we plot several lines connecting the points of the same value. As you can see, this is an area, and here in this area we draw several lines. These lines are of same value. Now the value of those lines may be of different properties, may be of different the types depending on the character. These lines are named different. Say for example, these lines can be drawn depending on temperature. So here you can see that these lines joining the points of same temperature. If you consider this temperature minus 10 degrees centigrade, so all along this line, all the points above this line have the same temperature values. That is why those points are joined through this line. So in this case, this line is known as isotherm. Iso means same or equal, and therm is for temperature. Similarly, they can be plotted on the basis of rainfall. That means the lines or the points having same amount of rainfall, they can be also joined, and these kinds of lines are drawn. Similarly, lines can be drawn on the basis of height or elevation or depth. So here, if we draw these kinds of lines, that indicates that within this line, all the points indicate same elevation or same depth or same height. So then we get these lines, and when these lines indicate the elevation of different areas having the same altitude values, having the same height values, these lines are known as contour lines. So contour lines are the lines along which all the points have equal elevation. Now, in topographic map, we mainly depict the elevation along with the other informations. So producing contour lines for an area is must in a topographic map. Now elevation in a topographic map is referred with respect to a fixed reference plane, as I already mentioned you. Now that reference plane for our use is the mean sea level, that is the average sea level between the tides, between the high tide and low tide. The average sea level is known as mean sea level. So in every place of the earth, in every point of the earth, we measure elevation or we measure depth with respect to this fixed reference point or reference plane, sorry, that is mean sea level, and the elevation or the depth is measured in feet or meters. So accordingly, the contour lines, that is the lines of equal elevations, they are described, they are denoted in the map in feet or meters. Now what we get actually in an area, suppose this rectangular area we are studying, we are surveying in our geological purpose, we get different points. You can see there are some points named also A, B, C, along with other points also. And we get the altitudes. They may be in terms of feet or in terms of meter of these all these different points. So you can see the values. There are some 80 values, some values are 60, some are 50, and some are 70. Okay. Now, if you get these kinds of different values of elevation of an area, so your first job is to draw the contour lines. So if we try to draw the contour lines, we can first draw the equal elevation points and join them. So here you can see we join the all equal elevation points in a circular pattern, in a closed pattern. All points of height 80 feet or 80 meter, we have joined them. Similarly, the points joining the 70 feet or 70 meter heights, we draw the contour lines of 70 feet or 70 meter. Likewise 60, 50, and 40. So this way, after measuring the heights or depths of individual points, individual locations, we join the points having the same elevation or having the same depth. So these are my contour lines. Now, if someone asks you to determine the value of A or determine the value of B or determine the value of C, which is in between two successive contour lines. Here you can see that point C is in between at the middle part of the contour line 50 and contour line 60. So if we observe that this contour line indicates, that means this point here, this point indicates 50 feet or 50 meter value, and this point indicates 60 feet or 60 meter value. If we join this line, then over this line from 50 meter to 60 meter or from 50 feet to 60 feet, the C point lies. Now, in this line which I draw, all the points above this line, they have different altitude values because this line is cross-cutting the different altitudes. And we see that C is lying in between the 50 feet and 60 feet height. So we can divide these lines in different proportions. Say for example, we divide the from 50 to 60 in 10 divisions, 10 finer divisions, and we try to observe that at which division the C point lies. So we can count 1, 2, 3, 4, 5. So C point lies after 5 interval from 50 meter contour. So the value of C point, that means the value of altitude of the C point, will be 55 meter. Similarly, in this way you can measure the value of elevation of B point and the value of elevation of A point also. So in this way, in of any point within this given area, after formulating, after constructing the contour lines, if someone give you any point, or if someone asks you the elevation, the height of any point within this given area, we can easily determine the height or the depth of that point with the help of these contour lines. Now, what we actually do to draw the contour lines? As I already told you that contour lines are connecting the points of equal elevations. So basically contour lines are the lines which give us an idea about the relief. Relief means that may be height, that may be um, elevation or that may be depth. So it gives us an idea about the relief of an area. Now, what we actually do, suppose you are visiting an area and you see these hillocks. So along these hillocks, there are different points of different altitudes. Say this point is of 500 feet, this point is of 1000 feet, 1500, likewise. And it's a three-dimensional figure. This hillock is three-dimensional. In this picture, we can see only a section, only a part of this hillock, and that is why we can see it in two-dimensional. But originally in field, it is a three-dimensional object. Now, what our contour map shows is the two-dimensional representation of any three-dimensional object. So what we basically do, we take all these points above this object and project them in a horizontal surface. So if you can see all the points, the 500 points is projected here in this horizontal surface, the 1000 feet point projected here, similarly the 3000 feet point projected here, and it is done for the entire three dimensions, for all the dimensions, for all the points of this hillock or of this object. So what we did actually this three-dimensional object represented now in a two-dimensional view. It is the same view one observe this hillock from the aeroplane. So whenever you are passing by an aeroplane over this object, it appears like this. So you are only observing these kinds of different circles having different elevations. So basically the three-dimensional thing is now visible to a plain paper in two-dimensional, because in your copy, in our papers, we cannot show a three-dimensional object. So thereby we represent that three-dimensional thing into two-dimensional body in our plain paper. This type of map, which represent a three-dimensional object in two-dimensional perspective, this is known as contour map. And contour map consists different lines having equal elevation. That means different contour lines. Now in contour lines map or in contour map, we can see contour lines having different values. So the distance between two successive contour lines, say for example, here you can see the value of 800 of this bold contour line and the immediate next contour line, say for example this one. The distance between these two contour lines is known as contour interval. Now keeping it in your mind that the contour interval between two successive lines may not be same throughout the entire object. As you can see, for this contour interval, for these two contour lines, the contour interval at this location is much higher compared to the contour interval at these two lines, although we are considering the same two contour lines. So contour interval, that means distance between two successive contour lines, may vary at different parts of the object. Now in a contour map, we can also see that among all the contour lines, there are some contour lines which are heavy, which are bold, or which are darker compared to others. These are known as index contour lines. say for example here it is 700, 800. These are the contour lines for which the values are given, and the intermediate contour lines, you can see that here the values are not given. So if I write all the values of all these contour lines, then it is very much uh, hazy or very much heavy for one to write. If someone want to write all the values for these contour lines, for this one, this one, this one, this one, this one, so it becomes very much clumsy. So to avoid that clumsiness, we are choosing some whole number value indicating contour lines and demarcated them with some bold, heavy, darker lines and put the values of that contour line. Generally, for every fifth contour line, we use this index contour line. If you count, this one is the 700-meter contour line. Then after that, 1, 2, 3, 4. Again, the fifth one is heavy or bold. So again, after 800, it will be the 900. So 1, 2, 3, 4, and 900. So here the contour line are plotted in every 20-meter interval. So if this one is 700-meter, this is 720, 740, 760, 780, and 800. So here contour lines are plotted in 20-meter interval. That means altitude difference is shown in 20 meter. Again, this altitude difference can be of various types. It may be of 50 meter, it may be of 100 meter. So we draw those contour lines in the contour map according to our necessity. Okay, and generally these index contour lines are plotted in every fifth repetition. Now there are some basic characteristics of contour lines. Contour lines, as we already know, these are points connecting equal elevations. So all the points over a contour line, they have the same altitude or same depth value. Contour lines never split. That means contour lines never bifurcate or trifurcate. They cannot be divided. Different contour lines never cross one another. So you can see no two contour lines having different altitude, they cannot cross cut each other. So it's a obvious reason 700-meter and 800-meter cannot cross cut each other. So that is why the lines joining those different altitude points, they also never cross one another. Spacing between contour lines, that is the contour interval, is related to the steepness of the slope. As you see in that hillock picture, when the contour lines are widely spaced, that indicates a gentle slope. And say for example, suppose this one a hillock, what you observe in the field. Now, if this one is the certain value of, say for example, this one is 100 meter and this one is 200 meter. So similarly, in this side of the hillock, you also get the 200-meter point and the 100-meter point. Now, if we plot them in a horizontal paper, so that will be traced in the horizontal paper at that point. The 200-meter will be projected at that point. So now in the contour map, this is the contour interval of 100-meter and 200-meter for this side of the hillock, and at this side it is projected here. Sorry, here you will get this point of 200-meter, and this is the point of 100-meter. So in this side the contour interval is that. So you can get an idea that whenever the slope is gentle, you can see that for this hillock, this side having the slope is gentle, this angle is low, whereas in this side this angle is relatively high compared to this one. So here, for this side of the hillock, the slope is gentle and it is identified by the distance between between two contour lines. That means contour interval is higher, indicates that the slope is gentle. But when contour interval is low, that means contour lines are closely spaced, then it indicates a steeper slope. Next, evenly spaced contour lines. If you can see that in an area, all the contour lines, all and their contour intervals, they did not vary. They spaced evenly after a fixed distance. So that indicates a uniform slope. That means slope on that area did not vary from one point to another point. Oppositely, if you see that the contour lines are unevenly spaced, then you can see that the slope of that area is irregular. That means slope in that area varies from one point to another. Somewhere it is steeper, somewhere it is gentle. When contour lines go across stream valleys, then they form V-shaped contour lines are formed with their apices pointing upstream. So V-shaped like this one, V-shaped contour lines are formed with their apices, that means the pointing tip that indicates the upstream. You can see in this picture. Here it is a 250-meter contour line and you can see the V here. So this one is the flow direction of the river. This portion, this one. Similarly, another V you can observe for 250-meter contour line in this portion. For 260-meter contour line, another V is observed in this portion. And as I already told you, the apices, the pointing tip of V is always indicating the upstream side. So this one is the upstream side, this one is the downstream side of the river. So river flows from this side to this side, and for this river flows from this side to this side. Hills, knobs and mountains are represented by closed contours, as you can see in this picture. These are the closed contours, not open. But if you see the 260-meter contour lines, this is not closed, this is an open line. But 270-meter contour line, you can see it is closed. It's a closed contour line which indicates that it is a hill, knobs or mountains. Similar type closed depression for a volcanic or meteoric crater, that means a depressed area or a sinkhole, those are represented by closed contours but with some perpendicular small lines which are known as hachure marks. You can see in this part of the all these smaller lines, smaller ticks perpendicular to the main contour line, these are known as hachure marks, and these kinds of hachure marks in your contour map definitely indicates that it is although a closed contour pattern, but this is indicates a depression, a basin or a sinkhole. Okay, so both mountain range and basins or sinkholes indicates closed contour lines, but we differentiate them in our contour map on the basis of these hachure marks. As well as if you can observe the contour line values, you can also get an idea about the original feature. You can see that the values of contour lines, that means the altitude values for these mountains, increasing towards the center portion of this closed uh, outcrop or closed contour pattern. You can see the values 270, 280, 290, the values are increasing, whereas in this case you can see the values are decreasing towards the central portion, 260, 250, 240. So on the basis of the both the contour line values as well as these hachure marks, we can differentiate, we can distinguish which one is the contour pattern for a hill or the contour pattern for a basin or a depression. Now, along with the contour lines in a contour map, there are marked by some specific points in the contour map as well as in the original ground. When these kinds of marking are produced in the original field, in the real field area over the earth's surface, and they are represented in your map by these kinds of values or these kinds of markings. Say for example, here it is marked as BM2296. This indicates the benchmark. At the same time, there are some points which are indicated by plus sign in the contour map or X sign in the contour map. That indicates the spot elevations. That means these are the elevation points which is not lying over the contoured lines. So you can see this X point is not lying in these contour lines, but we have to know the value of that point. So that is why we indicate that point as X or plus sign and write the values of that point. So these kinds of altitude values of any point which is not lying over a contour line, they are known as spot elevations. Now the difference between spot elevation and benchmark is something special. Spot elevations can be of any uh, point over the earth surface, any point. It may be a top of the hill, it may be this point, it may be this point. So any point in an area, if the elevations are written, they are the spot elevations. But benchmark are something special. Suppose your area, in your area, the Tropic of Cancer is passing. So you are uh, try to mark the altitude values at those points from where the Tropic of Cancer is going. So for those cases, we use the term benchmark. So benchmark term is used for some special cases, and from the local geological bodies of the country, these kinds of brass plates are put on the ground on the earth's surface, and in the map they are indicated by these kinds of markings BM 2296, or it may be any 2296 means this is the altitude values and BM means benchmark. So if this point altitude value is 60 meter, then it will be marked as BM 60. Now in the contour map, apart from the contour lines, apart from the benchmarks or spot elevations, there are different colors observed in the contour map, and these colors indicate different features, different objects within the given area. Say for example, whenever we see the color brown in different shades of brown, we identify them as the higher altitude portions of those areas. They represent the hills, the mountains. Compared to the higher altitude means they are higher in elevation with respect to mean sea level. Whenever we see the shades of blue in your contour map, they definitely indicates some aquatic bodies in your given area. That means there may be lakes, there may be ponds, canals, river, lagoons, even sea also. Whenever we see black or red color, darker color, those are mainly of roads, railroads, land boundaries. For cultural features, we again used black, red, yellow. These are of different shades that indicates towns or cities. For vegetation, we use the color green of different shades. For dense forest, it is be darker green. For lighter forest, for sparse vegetation, we use lighter green. So different shades of these colors are used along with the contour lines to indicate different different features within your given area. Now, along with the colors, there are different symbols indicating different features in your given area. Say, for example, if over your area an international boundary is passing, so that will be marked like these kinds of dotted line. State boundary if passing, so that will be marked these kinds of dotted line. So the same dotted line is uh, given for indicating different state boundaries or international boundaries or city boundaries, but there different varieties of those dotted boundary lines are used. So likewise, different objects, as you can see, temple, church, mosque. Here you can see the dams, streams, roads, metallic road, uh, different bridge, footbridge. So all these kinds of whatever we see in our surroundings, those are represented by different symbols as well as different colors. You can also see that whenever the any kind of specific symbol is not given for any feature, say for example here you can see the forest, one is reserve forest, one is protected forest. So specific symbol, people are not able to give any specific symbol, so therefore they use the abbreviated form. For protected forest, they use the PF. For reserve forest, they use the abbreviated form RF. So whenever in your map you see that in capital letter RF is written, that means that is a forest area which is reserved. That means it is an reserve forest area. So these kinds of colors, these kinds of symbols are used in a contour map to depict all kinds of features present in your studied area. Now, the most important thing, it has to be provided in your contour map, that is the scale of your contour map. Now, the scale of your contour map is basically the relation between 2 points on the map and the actual distance between those same 2 points on the ground surface. So what we basically do, suppose someone asks you to show the contour map or to draw the contour map of India. Now, if someone try to draw the entire Indian map in the same size, so it will require a lots of papers to cover and it will be a heavy one. So what we do in our practical sheet, what we use, we reduce the size of India so that we can represent them in our practical copy. So this reduction of size for representation in our practical copy is based on some scale, and that scale has to be provided. It is must to provide that scale with the contour map. And if someone try to measure the original distance between any 2 points or between any two regions, then they can measure the distance of those 2 points with the help of the scale. Now, how scale is used? Scale may be used in three ways. The first type is verbal scale. Here, the actual ground distance is compared or equated to a smaller dimension and representing it on the map. Say for example, we are verbally saying that 1 centimeter is equal to 10 kilometer. So this type of representation of the scale is known as verbal scale. What does it mean? It means that the distance between 2 points in original in ground, which is 10 kilometer, that distance is shown in your map by 1 centimeter. So if there are 2 points in your map, say for example A and B in your map, and in your map by the scale you measure the distance between these 2 points, say for example it becomes 2 centimeter. So according to this scale, if the distance between these 2 points in your map is 2 centimeter, then the distance between these 2 points in original, in ground, in actual will be 20 kilometer. So the entire 20-kilometer distance between these 2 points are now represented in my map as 2 centimeter, using scale by which we can reduce the original scale into a much smaller version. The second type of using a scale in contour map is the graphic scale, or we also called it as bar scale. Here, graphically, by drawing a linear distance in our map, say for example this straight line or these kinds of patterns in our map, we depicting the scale of the map with respect to the actual one in the field. So if I draw this linear line, this line, and above it we write 1 mile, that means in the map this much of distance in my contour map represents the original distance in the ground as 1 mile. So suppose this one is 2 centimeter in your map, so that means in verbal scale it is be represented as 2 centimeter in your map is equal to 1 mile in actual. Similarly in this type, if it is 1 centimeter, that means 1 centimeter in your map is half kilometer in field, half kilometer in original. And the third type of representation of scale in the contour map is fractional scale or ratio scale. It is also called representative fraction. What we actually do here, we represent the map scale, contour map scale, and the original field distance. We put them or we show them in some ratios. Suppose in this case, and this ratio must be of same unit. So suppose for this one, my 1 centimeter in contour map is equals to 24,000 centimeter. I already told you that for giving here in fractional scale, they must be of same scale. In previous cases, they may not be required to have in the same scale, but in this case, to represent them in this fractional scale or representative factor RF scale, you both these should have in same unit. So 1 centimeter in map will be 24,000 centimeter in original. That is represented as 1 is to 24,000 or 1 by 24,000 in this way in your contour map. So by this three way we can express, we can represent the original distance between any 2 points in the field with some smaller dimension, with much smaller dimension in the map. Say for example 10 kilometer of original is represented as 1 centimeter. That is the necessity or purpose of the scale, and from that scale value we can determine the dimension, the length, the width, the distance of any two given points of any object. We can determine the original values. So if we summarize what we find in our contour map, what should be given in a proper scientific contour map, the first and foremost is to show the geographic north direction. This one is very important because I already told you that whenever we determine the values of altitude or depths, that is determined with the help of some latitude and longitude. And as you know, that latitude longitude are represented with the help of geographic north. So in case of contour lines, as these contour lines represents the elevations or depths of several points, so in contour maps, geographic north must be noted first. Second, there should be different contour lines, and all these contour lines indicates different elevations. So one elevation contour line indicate all the points having the same elevation or having the same depth. There may be some index line which marks as bold or which is much darker in color compared to others. There may be different colors or different symbols, say for example these hature marks that represents the a basin or a depression. And lastly, there should be a scale like that. So it is a graphic scale what I shown here. So this much distance in the map is in original 1 kilometer in the field. So these five properties, five characters have to be there with a complete scientific contour map. Now, along with this, we get some additional information simply by observing or simply by studying these contour maps. We can give or we can produce the highest possible elevation, that is the, say for example, this top of this hillock. So we can write it here by indicating a cross or by a sign X, that is the spot elevation. Contour interval, from contour interval we can get an idea about the slope, and we can also determine the exact values also, that we come in our later class. But from contour interval we can determine or we can get an idea about the slope, such that in this map you can see that in this portion you can see the contour lines are very close to one another, whereas in this portion you can see that contour lines are far apart from one another compared to this side. So in this part, as contour lines are close to one another, that means the spacing between two successive contour lines is lower, is less in distance, that indicates a relatively steeper slope. So this part within this figure, this part indicates a steeper slope, whereas as in this part the contour lines are distant from one another, this part indicates a gentle slope for this particular contour map. Mind it, this is for this particular contour map. Say for example, in another map, in one side you can get these contour lines like this, like the contour interval like this one, whereas in other side the contour interval is like this. So for this map, this one is the steeper slope portion, that is, as the contour interval in this portion is narrow, whereas the contour interval in this portion is higher. So this one is the gentle slope portion. So the contour interval between two successive contour lines, it will be varied from different parts of any given map, or it varies in different contour maps of different regions. Steepest slide, steepest side have dense contour lines, that means contour intervals are low, and along with that other features are also observed, such that the buildings, dams, ponds, rivers, forests, they are also shown by different colors and different symbols. Now from a given contour map, say for example this contour map is given to you. From this given contour map we can draw a profile. Profile means that it is a section of the original uh, feature looking from one side. As I already showed you in the previous picture, a picture of a hillock. So hillock is a three-dimensional object and we observe that hillock from one side. Okay, so that is called the profile section of any feature. So if someone given you this kinds of topographic map having different contour lines, having points, spot elevation points at different areas, having a fixed scale indicating the geographic north, and the contour lines values are also given, that is they are in feet with a stream flowing in between, as here it is a V of contour line and the tip of the V indicating the upstream side. So definitely this river is flowing from north to south, as this one is north direction. So from top to bottom of the map, this is top side, so river is flowing in this direction and there is a oceanic body. It should be colored with blue, but here it is not. Okay, now if someone want to know the topography of this map from point A to point B, as you can see that there are two points given marked as A and B, and within them they draw a dotted line. So they want to know the variation in elevation in a profile section between these 2 points. So basically to draw the profile section between any 2 points within the given topographic map or within the given contour map, what we basically do. So first we place a sheet of scrap paper over the map connecting the points A and B. Here it is the point A and it is the point B. Now we have to mark the locations and value of each contour line that intersects with your scrap paper. As you can see, we are marking these uh, intersects of this contour line with this scrap paper, all the intersecting points of contour lines with the scrap paper. And simultaneously, we also note the height values, the altitude values at that intersecting point. Okay. Also, we have to note the points starting from which up to which we are marking or we are trying to do the profile section. So these A and B points are also marked. Now a vertical scale has to be chosen in your graph paper. In the second phase, you have to take a graph paper with lots of horizontal and vertical lines drawing already in the graph paper. We have to measure a vertical scale. Say for example, here we take 1 centimeter is equal to 20 feet. As you can see, here the scale is given in 20 feet. So it is our choice to take that 1 centimeter is equal to 20 feet if it is not given. But here you can see if it is given a scale, then we have to take the vertical scale according to the scale given in the contour map. So for simplification, here I uh, use the scale 1 centimeter is equal to 20 feet. Now you have to place the scrap paper at the bottom portion paralleling with the x-axis. So now my scrap paper has all the points, these intersecting points in the scrap paper along with these contour lines. All the points are in this scrap paper are already marked, and the values of these points, the altitude values of these points are already noted along with the starting and end points, that is the A and B points. This one is the A point, in the contour map, and this one is the B point in the contour map. So now when this scrap paper is plotted, this is my one point indicating a contour, indicating a height, indicating a altitude value. What is the altitude value of this point? This point is the equivalent to this point. So the height of this point is 100 feet. So now I placed this horizontal x-axis point, the intersecting point, original one, to the 100 feet value. Suppose this one is the 100 feet value. So I place them according to its original height. This 100 feet point is placed according to its original altitude value. Similarly, this one is 80 feet. So I placed this point according to its original altitude value. So like this way. The next one is 60 feet. So 60 feet should be like, about this one. So it is 60 feet. Next one is 40 feet. So it is here. Next one is 40 again here. Next is 60. This. Next one is 80 here. Next one is 100 here. And next, the last one is in 120 feet. So these points are plotted or put vertically from the x-axis into their original altitude values. Now, after plotting all these points having different altitudes, they are joined by simple hand. Sorry, this one is should be like this, by free hand. Sorry, my line is something deviating from the original point. So this, like this one. So this is my original feature, what is present in the field, and this is of a valley. That is why, as this one is a valley, from A to B you are passing, the values of altitude that are decreasing, a valley is there. That is why a river is flowing through this valley. If it was a hillock, then the river cannot flow from the top of the hillock. So because of these decreasing altitude values, there forms a valley, and the rivers, you can see the river flows within this valley. So this is the original feature, original topograph, original form of the surface whenever someone crossing from point A to point B. So this one is my, sorry, the point A. We have to join the point A. This one is my starting point, point A, and point B is somewhere like that. So we have to start from point A, as we have to draw the profile section from point A to point B. So although point A we did not get any particular height, so just by increasing the higher values of the contour line like little bit, uh, that is point A and that is point B. So this was my profile section for A, sorry, this was is my profile section from point A to point B of the map. And in this way, we can draw the profile section for any two given points observed in the contour map. So that's a brief idea about the topography and topographic map or contour map. I hope you can understand this. It will help you to understand, and you are now able to draw the profile sections which will be provided to you through some contour maps. Thank you.